Okay, so what we're looking at here, we have the blades of a wind turbine are 116 feet long. The propeller rotates at 15 revolutions per minute. And we're looking for two things. We're looking for the angular speed as well as the linear speed. Okay, so we're going to start this off with part A. We're going to be looking for the angular speed. So a revolution, right? One revolution is equal to 2 pi radians, right? If you go around one full time, I'm by no means an artist, but you have those wind turbines, something like this. You might see them if you drive to like Palm Desert, something like that. So the length of one of our blades is 116 feet long. It's not a very straight line. Right? And one full rotation of a blade, so say starting here, going all the way around, it would be a circular motion, right? One full revolution is 2 pi radians, right? So what we're seeing is because there is 15 revolutions per minute, that leads us to 15 times 2 pi, right? That's the same like revolutions, you could say radians if you want, per minute. But this is essentially what we're using to understand our angular speed, right? That angular speed, omega, so it's kind of like a W, it should be curved, it should not be pointy, and it kind of curves back on itself a little bit. So that omega value looks like a W, right, is theta divided by t, which would be time. And we're looking at 15 times 2 pi, right? That's that angle that we're moving. We could write this out, just 30 pi radians per minute for every 1 minute, okay? Because that's what we're measuring it in, right? So I would clean this up. This would be in radians. I would clean this up to just say omega, or that angular speed, is 30 pi radians per minute. Okay, so again, in terms of kind of that angular motion. So how do we get to our second part? How do we get to our linear speed? Well, the formula we have V is S over T, or we can equivalently say, let me put or here, V is equal to R theta over T, right? So for us, that value of R, right, that's our radius. So that would be, we can even list it over here, 116 feet, right? The value of theta is really coming from what we found here, right? I guess I could have called this theta. In that we're looking at theta is that 30 pi, right? So this V is going to be 116 times 30 pi divided by that same time, which is just 1 minute, right? And if you throw that on a calculator, I'm going to do it initially where pi is just part of it. So 116 times 30, we can say 3,480 pi feet per minute, right? Remember, feet kind of overrides radians because radians is just there. It's like a non-unit unit of measure. If we multiply this by pi, though, if we actually multiply it in, we get this linear speed, 1,932.74 feet per minute. Okay, so there you go. That is your second part, your linear speed. And I do want to mention right here, those units of measure are very important as we go through this, right? You don't want to leave them out.